Okay, great. So you are preparing for engineering services. When is your interview, Prashant?
The 14th December.
14th December you are having your interview. Good.
Yes, sir.
So Prajwal, let's start your snap. Before that, please introduce yourself briefly to me.
Then myself, Prajwal Srivastava. I belong to Varanasi, Uttar Pradesh. I did my initial schooling from Varanasi and further from Kota, Rajasthan. And I did my graduation BTech in mechanical engineering from IIT Roorkee. Currently, I am preparing for engineering services exam.
So when you completed your BTech?
2021.
21. So from last 1 year you are preparing.
Yes, sir.
Fine, fine. So what is thermodynamics, Prashant? And what do you like about this subject, thermodynamics?
So thermodynamics is basically a branch of science which deals with the interaction of, which deals with the study of interaction of between system and surrounding. Study of energy interaction between system and surrounding.
So
And
how, in what way actually energy exchange or energy interaction is possible between two bodies?
sir, by sir heat and work transfer के through sir होता है sir, means heat transfer.
So suppose if there is no heat and work transfer between two bodies, then there will be no energy interaction. Like suppose we are having a closed adiabatic system.
Yes, sir. Closed adiabatic system, sir, mass transfer के through हो सकता है sir, मतलब mass अगर हो रहा है तो transfer.
So with mass transfer also energy interaction is possible.
Yes, sir. जैसे मतलब open closed adiabatic system sir. तो close में तो sir mass transfer भी possible नहीं है sir.
तो वहां पे क्या रहेगा, एनर्जी इंटरेक्शन नहीं होगा
सर? वो तो आइसोलेटेड सिस्टम हो गया ना, मतलब क्लोज एडियाबेटिक सिस्टम तो सर आइसोलेटेड सिस्टम हो गया, तो उसमें एनर्जी इंटरेक्शन.
सो देयर विल बी नो एनर्जी इंटरेक्शन फॉर आइसोलेटेड सिस्टम.
सर फॉर क्लोज्ड आइसोलेटेड सिस्टम इन माय
ओपन ही होता है आइसोलेटेड सिस्टम. वी आर हैविंग सम ओपन आइसोलेटेड सिस्टम आल्सो.
ओपन आइसोलेटेड सिस्टम सर बेसिकली थर्मस. नो सर, ऐसा तो नहीं होता है सर.
अच्छा, व्हाट डू यू अंडरस्टैंड बाय कंजर्वेशन ऑफ एनर्जी, प्रज्वल?
सर, कंजर्वेशन ऑफ एनर्जी स्टेट्स दैट energy can neither be created nor be destroyed. It can only convert from one form to another. Yes, sir.
So how energy this first law is different from second law?
The first law deals with the quantitative analysis of the heat and quantitative analysis of energy, while second law deals with qualitative analysis. Means in first law only we don't consider कि मतलब कैसे हो रहा है, मतलब जैसे सेकेंड लॉ में तो सर हम क्वालिटी एनालिसिस करते हैं कि क्या कहते हैं, अगर हीट ट्रांसफर हो कि जैसे हम एक कप ऑफ टी रखते हैं सर, तो सर हीट ट्रांसफर वो हम कहेंगे कि ये सिस्टम से सराउंडिंग के थ्रू, मतलब कप से उसकी तरफ होगा, मींस एनवायरनमेंट में अगर वो हाई टेम्परेचर पे है, नॉट फ्रॉम एनवायरनमेंट टू कप. मींस सर यहाँ पे क्वालिटी की डिस्कशन होती है, मतलब ये होता है सर.
Prajwal, what do you understand by continuum thermodynamics?
So continuum analysis states that any matter can be assumed to be continuous without any void being present. Means it deals with macroscopic analysis. The continuum analysis states that it states that the whole matter can be assumed to be continuous without any void being present. It is valid when the mean free path is less than the system dimensions. And it does not means yes sir, it's nice.
Acha, what do you understand by state functions?
So, state functions are sir point functions. Means state functions are point functions. They do not depend on the path followed. For example, sir, internal energy, entropy, these are state functions, while path functions are different from these. They depend on the path followed from one state to another.
Acha, can you give me some example where we will have a kind of reversible work transfer, or work transfer will be always irreversible? What do you feel about this, Prajwal?
So work transfer, sir, can you repeat the question?
I asked you, can you give me some example related to reversible work transfer?
Reversible work transfer.
And is it possible that can we transfer work reversibly?
Transfer is there. सर टर्बाइन में सर मतलब स्टेडी फ्लो डिवाइस है, तो सर अगर आइसेंट्रोपिक मतलब उसको लें तो रिवर्सिबल वर्क ट्रांसफर हो रहा है सर, वहाँ पे वर्क जो प्रोड्यूस हो रहा है वो रिवर्सिबली प्रोड्यूस हो रहा है, मतलब ऐसा।
So work which we are producing in turbine is reversible work.
यस सर।
अच्छा,
मीन्स
क्या
अगर
लग
सर
रहा है?
आइसेंट्रोपिकली अगर देखें, अगर उसमें लॉसेस ना कंसीडर करें, मतलब जो मतलब हाँ सर सर अगर हम उसको आइसेंट्रोपिकली कंसीडर करें विदाउट एनी मीन्स नो हीट, आइसेंट्रोपिक कंसीडर करेंगे तब सर हो सकता है, मतलब तब रिवर्सिबल हो जाएगा सर प्रोसेस। मीन्स इरिवर्सिबिलिटी अगर नहीं कंसीडर करते हैं वहाँ पे, तब हो सकता है सर। अगर वहाँ पे फ्रिक्शंस और लॉसेस जो हो रही है उसको अवॉइड कर दे, तब वर्क ट्रांसफर रिवर्सिबल हो जाएगा सर।
अच्छा प्रज्वल, what is the difference between internal energy and enthalpy?
Internal energy basically represent the molecular thermodynamic energy of matter, while enthalpy represent the capacity of fluid to carry energy itself when it flows in and out of the control volume. So basically enthalpy was determined when it was H is equal to U plus PV, sir. Sir, enthalpy basically capacity of the fluid to carry energy with itself, while internal energy is the molecular thermodynamic energy of the matter.
Fine. So if you will consider a air conditioner, suppose
Yes, sir.
there is a window air conditioner we are using
Yes,
in
sir.
a particular room. So what do
Yes,
you
sir.
feel? What kind of energy transfer or energy exchange is taking place between the system, the AC? AC is our system, or what you can say, the
Yes, sir.
working fluid which is moving, which is circulating inside the that air conditioner. That is our system. So what kind of energy exchange is taking place, Prajwal?
सर एसी को सिस्टम मान रहे हैं, और सर एक बार क्वेश्चन रिपीट करेंगे सर, थोड़ा नेट
We are using some AC to maintain some lower temperature in a room.
यस यस सर।
So the working fluid which is circulating in the air conditioner, that is our system. Okay.
अच्छा सर, यस सर।
So now you need to tell me what kind of energy exchange, energy transfer is taking place between system and surrounding.
सर ये जो वर्किंग फ्लूइड है सर, वो जो हमारा स्पेस जिसको हमें कूल करना है उससे हीट एक्सट्रैक्ट करेगा, और वहाँ पे लेटेंट हीट ऑफ ट्रांसफॉर्मेशन होगा, मतलब वो वेपराइज वहाँ पे फेस चेंज
अच्छा
वो
चलो,
होगा।
इस केस में suppose because this system is closed system, so for
Yes, sir.
entire cycle, what you feel? Cyclic integration of dq will be zero, positive or negative?
So for what sir?
For that air conditioner which we have
Yes sir.
considered, the cyclic integration of heat dq,
Yes sir.
that will be what, zero, positive or negative?
Cyclic integration of heat will be 1 minute 6. सर साइक्लिक इंटीग्रेशन ऑफ हीट विल बी सर मीन्स सर देखिए सर, उसमें सर जब हम हीट लेंगे सिस्टम से, मतलब जो हमारा स्पेस है उससे कुछ हीट आएगी और फिर हम वर्क ट्रांसफर करेंगे, तो जो फाइनली हीट रिजेक्ट होगी वो ज्यादा होगी, मतलब जो फाइनल हम एटमॉस्फेयर रिजेक्ट करेंगे दूसरी जगह वो ज्यादा होगी। तो सर साइक्लिक इंटीग्रेशन ऑफ हीट मीन्स heat rejected will be greater than heat added to the system. So
Means
sir,
cyclic integration of heat will be negative.
so heat rejected will be, yes sir, cyclic integration will be negative because rejection will be greater than heat addition to the system.
Okay.
Yes sir.
What about entropy? Entropy change of the universe?
Entropy change of the universe तो always greater than zero होता है सर, मतलब अगर अगर टोटल रिवर्सिबल प्रोसेस कंसिडर करें तो सर अगर कोई साइकिल तो रिवर्सिबल है सर, तो इसमें तो सर नेगेटिव हो जाएगा, लेकिन सर
नेगेटिव हो जाएगा।
नो सर 1 minute लेट मी। Entropy change of universe always सर ग्रेटर देन इक्वल टू जीरो होता है सर, तो मतलब इसमें तो
Mm-hmm.
तो सर नेगेटिव नहीं रहेगा सर साइक्लिक इंटीग्रेशन मतलब एंट्रोपी चेंज ऑफ यूनिवर्स सर इट विल बी ग्रेटर देन 0.
So cyclic integration dq by t, that dq is negative, and you are saying entropy change will be positive.
नो
Fine.
सर नो सर 1 मिनट
Mm-hmm.
अगर एंट्रोपी जनरेशन को देख लें सर तब सर नॉट गेटिंग सर नो आइडिया.
Mm-hmm. Okay. What is free expansion, Prajwal? What do you understand by free expansion?
फ्री एक्सपेंशन सर जैसे एक फ्री एक्सपेंशन इज द एक्सपेंशन सर व्हेन सर रप्चर ऑफ मींस द एक सेकंड सर सो 1 मिनट सर.
Mm-hmm.
Unrestrained expansion against vacuum, sir. When our system, when suppose we have a gas in our container, sir, a gas, and there is a membrane. Means once we divide the membrane, the system into two parts. One is isolated and one is vacuum, sir, and another in which we have gas, and there is a membrane or membrane is there, and we rupture it. The gas will expand against vacuum. The free unrestrained expansion against the vacuum is the sir free expansion here, sir. Of the gas in this, the sir final temperature both are same, but it's an irreversible process, sir.
Acha, suppose Prajwal, you are carrying some glass, a kind of glass plate or sheet, okay, and suddenly suppose
Glass, sir.
you yes, some kind of glass sheet you are having, and you are
Yes,
transporting it from some ground level to some kind of first floor,
yes,
but
sir.
suppose suddenly you dropped it.
Yes, sir.
So what do you feel? How which by which particular process we can represent that process of dropping of that ice or that glass plate?
Which process means, sir? By means I am not.
Suppose we
Sir,
want to
why?
represent it by a kind of thermodynamic process.
अच्छा सर ग्लास है हाइट से हम ड्रॉप कर दिए उसको.
Yes, yes, yes.
ओके सर 1 मिनट.
Mm-hmm.
हाइट से ड्रॉप the glass sheet. There is a glass
Yes,
sheet.
yes, yes, yes.
1 minute, sir. Not getting idea, sir.
Acha,
No
suppose
idea.
we want to represent that process on some TS diagram. So how you are going to
Yes, sir.
represent?
Means, sir, what? TS diagram?
TS diagram pe suppose we want to represent that process, state 1 to
Which?
state 2.
Yes, sir.
State 1, when that ice, that glass plate is there in your hand, and state 2 is when it is at the ground.
Yes, sir. Yes, sir.
How you will represent it on TS diagram?
Sir, if you can say, sir, its temperature will increase, sir. Means, if because it drag will act on it
Mm-hmm.
when we are dropping it.
Mm-hmm.
So, इसकी no idea, sir. No details.
Okay. Prajwal, what is your understanding related to second law of thermodynamics?
So the second law basically deals with the qualitative analysis of the means. There are two laws given by two scientists,
Mm-hmm.
Kelvin Planck and Clausius, sir.
Mm-hmm.
So Kelvin Planck's statement was that, sir, when it is impossible to design a heat engine which which only exchanges heat with a single thermal reservoir and produces work. So it basically implies perpetual motion machine of second kind whose efficiency is 100%, which is impossible. While Clausius sir state that it is impossible to design a work-consuming device, maybe refrigerator or a heat pump, which transfer heat from one thermal reserve, one temperature to another temperature without consuming any energy from outside. I mean, so it's violates. it implies, sir, COP means COP is equals to uh, 1 minute.
Mm-hmm.
So means it basically the Clausius statement says it does not. It is impossible to transfer heat from one thermal reservoir to another a higher temperature thermal reservoir without consuming work. Means it is impossible to design a heat pump or a
Achha,
refrigerator.
suppose a particular device is violating second law of thermodynamics. So what do you feel? It
Yes,
is
sir.
also going to violate first law?
So no, sir. ऐसा मतलब हो may be possible or no, sir. It is not mandatory.
Mm-hmm.
Means it can violate second law, but it can follow first law, sir.
Mm.
तो वही जैसे
Okay.
एग्जांपल दिया था सर कि जो कप ऑफ टी वाला था तो उसके थ्रू
Mm-hmm.
कर सकते हैं
Mm.
मतलब सेकंड लॉ वायलेट कर रहा है लेकिन फर्स्ट लॉ कर सकता है वैलिड सर तो इसीलिए सर सेकंड लॉ आया था कि ये पॉसिबल नहीं है फिजिकल वर्ल्ड में
Mm. ठीक है. ठीक है. Prajwal, I think now I can provide you the feedback.
यस सर
Prajwal, you are trying very well. You are approaching each and every question, because what I feel for these kind of interviews, if you are someone having engineering services or some kind of research organization interview, they are going to check your approach, actually how you are approaching, how you are answering a particular question. So they are going to give you sufficient amount of time to answer a particular question. Okay, but you
यस
need to
सर
try, you need to approach
यस सर
to get answer of each and every question. Okay,
ओके
तो ठीक लाइन पे आप आंसर कर रहे थे. आई स्टार्टेड विद some questions related to thermodynamics, first law, second law, what is the difference. You mentioned about TMM1, okay, those kind of concepts you mentioned, and right line you answered. मेरे ख्याल से आपको जो दिक्कत आई, दो क्वेश्चंस में you faced problem. Okay, one related to that glass plate, and one more I asked you, I
तो
think.
रेफ्रिजरेटर वो एसी वाला सर
Yes, AC का जो एयर कंडीशनर का क्वेश्चन था.
तो उसका आंसर क्या होगा सर बता दीजिए
Yes, I'm going to discuss with you, don't worry.
यस यस
Prajwal, you know, AC is not a work producing device. Okay,
यस सर
even we are supplying work in an air conditioner, so we are doing work on the system. So net work transfer is the negative. Okay, work done on the system. So if net work transfer is negative, then obviously net heat transfer will also be negative. So
यस
that
सर
point is
नेट
very right. You mentioned कि sir,
यस सर
cyclic integration of heat will be negative. So
यस
that will
सर
be cyclic integration of Q, that will be less than zero in case of a refrigerator.
यस यस
Okay. In case of heat engine, that will be positive. Now the
यस
question
सर
arises: what is entropy? Entropy generation. So if
यस
we
सर
are considering the system,
यस
system and surrounding, so in a complete cycle, because we are considering a cycle, na, Prajal? So
यस यस
entropy is a property. So entropy change for the complete cycle, it will be zero. Entropy change of
सर
the system in a complete
यस सर
cycle.
यस सर यस सर यस सर
Now, what will be the entropy change of surrounding? What you are doing?
सर
Like we are picking some heat from the room. Okay, that is
यस सर
Q by temperature of the room. Okay,
यस
that is what that is going to result in a decrease in entropy of the room.
यस यस
And then
सर
what we are doing? We are dumping some heat outside.
यस सर
So net we are adding heat only into the what surrounding.
यस सर यस सर
And you know, when we are maintaining some steady state temperature inside the room, so room entropy is also not changing because we are maintaining some steady state temperature. So actually, what is happening from the outside, some Q amount of heat is continuously adding inside the room, and some QR amount of heat is continuously rejecting inside the outside the room. Are you getting? तो
वन
surrounding
सेकंड
से मतलब अगर हम हाँ again you need to listen. If you will
यस सर
consider room is in steady state,
यस सर
most of the time suppose we are maintaining some 20 degrees Celsius temperature inside the room. So room is in steady state, so there is no entropy change of the room.
यस सर
But surrounding का entropy तो change होगा, and that is going to increase.
यस सर
Surrounding से दो तरह का heat transfer हो रहा है. One, you are the heat is leaking out inside the room. Okay, that is how much? That is a refrigeration effect which we are getting. Yes or
यस
no?
यस
So that is refrigeration effect divided by temperature of the surrounding. Okay, that will be what? Negative.
यस सर
But again, there is some heat through the condenser is entering into the surrounding. That is what QR divided by temperature of surrounding.
यस सर यस
So if you will take TO, temperature of surrounding, as a LCM, what you will get in the numerator? You will get minus refrigeration effect plus heat rejection. And what is that
यस
plus heat rejection? Heat rejection is nothing but the sum of refrigeration factor plus work.
Yes, sir.
So solving this, what you will get? You will get W by temperature of surrounding. That is a net entropy change of the surrounding. Are you getting?
Yes, yes, sir.
And that is very right actually. Why? Because what we are doing in a refrigerator, we are converting work, whatever work we are giving, that we are converting into the heat only.
Yes, sir.
So suppose you are having a 2 ton का system है आपके पास, and that system is having COP2. So how much will be the entropy generation? That will be 1 under steady state condition. That will be 1 by temperature of the surrounding. Okay, and simply if someone will ask you how much is the irreversibility in that process, then what will be the irreversibility? Irreversibility will be entropy generation into TO. It means whatever
Yes, sir.
work we are giving, that entire is the irreversibility, because
Yes,
entire
sir.
we are losing. Suppose there is a
Yes, sir.
2 ton system with the 2 COP means 3.5 kilowatt work we are doing, okay, on the system, and that entire we are losing. Yes or no?
Yes, sir.
What's the
Yes,
idea,
sir.
Prajal?
Yes, sir.
I think one more question I asked you related to that I'm also going to discuss with you. Remaining all you answered. Okay, I am happy with your performance because your approach is looking fine. You are trying each and every question. Okay, तो वो important है Prajal. तो
Okay, sir.
यू आर हैविंग ए ग्लास प्लेट, तो उसको आप रिप्रेजेंट कर सकते हो विद सम, सपोज यू आर हैविंग इन योर हैंड्स इट इज एट सम हायर एल्टीट्यूड, तो
Yes, sir.
उसको आप क्या करोगे? बिकॉज एक्चुअली सिस्टम क्या है आपका? सिस्टम इज दैट व्हाट यू कैन से बॉडी है दैट इज मूविंग फ्रॉम वन रीजन टू अनदर रीजन.
Yes, sir.
तो अब इसमें जो आपका मास है, अब इसको दो तरह से आप बात कर सकते हो. If you can consider like a closed system also or a kind of flow system also. बट दोनों ही केसेस में
अच्छा,
आपकी दो चीजें क्या होंगी? व्हेन इट इज गोइंग टू स्ट्राइक विद द ग्राउंड, ऑब्वियसली इट इज गोइंग टू क्रैक.
yes, sir.
तो एंट्रोपी क्या होगा? इट इज गोइंग टू
बढ़
इंक्रीज
जाएगी सर.
सिस्टम के लिए,
Yes, sir.
अगर उसको आप सिस्टम
Yes, sir.
मानते हो. तो पहले आपको शुरू करना है कि व्हाट यू आर कंसिडरिंग एज द सिस्टम. ग्लास को
Okay, sir.
सिस्टम कंसिडर कर रहे हो, तो ग्लास क्या कर रहा है? सिस्टम क्या कर रहा है? मूव कर रहा है अभी.
Okay, sir.
एक रीजन से दूसरे रीजन पे क्या कर रहा है? मूव कर रहा है. तो ऊपर वाले रीजन पे उसका एनर्जी कुछ अलग है, नीचे वाले रीजन पे उसका एनर्जी कुछ अलग है, बट मास क्या है? दैट इज फिक्स्ड.
Yes.
जब नीचे स्ट्राइक करेगा तो एनर्जी इज कन्वर्टिंग इनटू व्हाट? दैट इज गोइंग टू रिजल्ट्स इन द हीट जनरेशन ओनली, because whatever
Yes, sir.
potential energy glass is having, that is going to convert into the heat energy when it is going to strike with the ground.
Yes, yes.
Okay, तो उससे obviously some kind of heat is going to generate, तो टेम्परेचर बढ़ेगा. एक
Yes,
बार
sir.
तो बढ़ेगा ही. After that again it can reach into some equilibrium condition by rejecting heat to the surrounding, but temperature
Yes,
बढ़ेगा
sir.
first, and entropy is also going to increase. Otherwise what you can mention कि sir I feel because this is not a kind of reversible process,
Yes,
ये
sir.
irreversible process होगा, and actually this is a very sudden process. Actually बहुत suddenly होगा ये process.
Yes, sir.
Okay, suddenly hoga, so you can consider it like a adiabatic process. There will be no heat transfer from the between system and surrounding, but it will not be reversible adiabatic, it will be irreversible adiabatic.
Yes, sir.
तो दो तीन चीजें आप इसमें बता सकते थे. तो adiabatic process, because process is very very fast, suddenly you are dropping some glass, it is accidentally it is dropping from your hand, so process is very fast, so it will be kind of adiabatic process. दूसरा टेम्परेचर बढ़ेगा, एंट्रोपी इज आल्सो गोइंग टू इंक्रीज. विद दैट यू कैन रिप्रेजेंट, एंड प्रोसेस विल बी इरिवर्सिबल बिकॉज एंट्रोपी इज गोइंग टू इंक्रीज फॉर द यूनिवर्स. ओके, तो उस तरह से आप इसको रिप्रेजेंट कर सकते हो. फाइन प्रेशर.
Yes, yes, yes.
तो ओवरऑल कुछ भी हमारे डेली लाइफ के प्रोसेसेस है, दे कैन रिलेट ओके विद सम काइंड ऑफ थर्मोडायनामिक प्रोसेस. Like they can ask you to give some kind of real life realization of constant pressure, constant volume, isothermal, polytropic process. Okay, तो जितने भी थर्मोडायनामिक प्रोसेस है उनका थोड़ा सा रियल लाइफ आपको इम्प्लीमेंटेशन, रियलाइजेशन पता होना चाहिए. ठीक है प्रज्वल, गुड लक.
Yes, yes.
थैंक यू.
Sir,